Okay, this video is going to focus on perimeters of similar figures. I decided to put this in a separate video. First, we're going to look at these quadrilaterals, and we're going to see that quadrilateral CBAD is going to be similar to, and whenever we write the quadrilateral names, we are supposed to put quad or quadrilateral to show it is a four-sided figure here. So we need to make sure that we're matching up our corresponding parts. I'll let you know the orientation is correct on this one. So A and E correspond. E will correspond with H, F is going to correspond with B, C is going to correspond with G. So C is listed first, C corresponds with G. B comes next, it corresponds with F. A corresponds with E. And D corresponds with H. All right, we'll come back and label this, these quadrilaterals in just a little bit. We're going to go ahead and find the scale factor used to create, and they mixed the letters around, it doesn't matter in this case, to create quadrilateral EFGH. Now what we need to see here are the words create, or the word create. This tells us that creating the quadrilateral is going to be, this is going to be our new. So that's going to be the one that goes in the numerator. New in the numerator. So with our new over old, I'm going to just do N over O for new over old. It doesn't matter, this case, it does matter what sides we use. We saw this previously because we only have one pair of corresponding sides that has a number, and that's going to be segment DC and segment HG. So the new quadrilateral EFGH, the new one here, we're going to put 10 in the numerator. Its corresponding part 2.5 in the denominator, finding that our scale factor will be 4. Again, we are going from, I'm just going to use the letters in alphabetical order, A, B, C, D, yeah they did, A, B, C, D to E, F, G, H. It got bigger, so our scale factor should be bigger than 1. Now we're going to do the exact opposite. Okay, we've done a problem like this. We're now going to see what the scale factor is to create quadrilateral A, B, C, D. So now A, B, C, D is going to be the new. So with our scale factor of new over old, we're going to use the same exact two numbers because we can't use anything else. So now A, B, C, D is the new. We're going to put the 2.5 in the numerator, and we're going to put the 10 in the denominator. This will simplify down. If you're at our school and use the calculators at school, because you have a decimal in numerator, it's going to pop up as 0.25. That is fine as a scale factor. Okay, but as a comparing it over here, seeing that they are opposites, we'll need that as a fraction. Now we're going to find the values of x, y, and z. We're going to do the same thing that we did in previous problem up here. We're going to use that scale factor for proportions. Okay, we can use the 10 over 2.5 if we want. I'm actually going to show you that way since we use the scale factor up here. What happens if you don't have the scale factor? Do you need to go find it? You probably should. Okay, but I will show you what happens if we just use the two sides that they have. So it does not tell us which one is new and which one is old. So what we're going to do is we're just going to follow our similarity statement up here. We're going to use quadrilateral GFEH or EFGH as the new and the other one as the old. Make sure that you do write small because you are going to need the room. Okay, solving for x. Okay, using new over old, we're going to use the 10 over the 2.5 as our first ratio. And set that equal to where x is. X is over here with AD. AD is going to correspond with EH. 16 has to go on top because this is the quadrilateral that went on top. EFGH went on top. It needs to stay on top with the other proportion or the other ratio. So we're going to put the 16 on top and the x on bottom. When we do our cross multiplication, here we're going to wind up with 10x. I'm not going to circle, I'm just going to draw the lines. 10x equals, we cross multiply 16 times 2.5, we're going to get 40. And then all we have to do is divide both sides by 10. X is going to equal 4. All right, let's take a look at Z. Or sorry, let's go to Y. For Y, I'm going to use the exact same 10 over 2.5. Make it easier for us. 10 over 2.5. Now we're going to find the corresponding sides Here, y is over here at FG. It's going to correspond with BC. Okay? The bigger quadrilateral, EFGH, has to go in the numerator, so y goes in the numerator. 3 will go in the denominator. Cross multiply, we get 2.5y is equal to 10 times 3 gives us 30. And then all we have to do in this case is just divide by the 2.5. We find that y is going to equal 12. And what I'm going to do is I'm going to kind of go back to x. We want to go ahead and make sure we're going to have to find perimeter. So up here, this side length is going to be 4. Y we found to be 12. Now we'll go find z. I'm going to use that same 10 over 2.5 equals. And so to find z is going to correspond with the 5. The 5 has to go in the numerator again. EFGH is going in the numerator. And then z will go in the denominator. Cross multiply, 10z equals 5 times 2.5 is going to give us 12.5. We divide both sides by the 10. Dividing by 10 just tells us move the decimal one place to the left. We end up with 1.25. Go ahead and go up here and label that. E and F are going to ask us to write in the perimeters. Okay, so we're going to, make sure I get this, let me zoom out a little bit. We're going to just perimeter, all you do is add up all the sides. So here, quadrilateral ABCD, this one right here, we're going to take those sides, 1.25 plus the 4 plus 2.5 plus 3. We add these, we're going to end up with 10.75. Now we're going to go find the perimeter of EFGH. Add 5 plus 16 plus 10 plus 12. We will find out we have 43. Taking these two perimeters, we're now going to find the ratio of the perimeters. We're going to use the same fashion of ABCD is old, EFGH is new. So we'll go ahead and put our new over old, and we'll write in what we have. New is EFGH, old ABCD. So we set up the ratio of the perimeters. Here in the numerator we want 43, and the denominator we want 10.75. When we simplify this down, we're going to get 4. Letter H is saying, how do the answers in part B up here compare to part part G? They're exactly the same. So we end up with the same ratio, which, sure why I put an R on there, same ratio, which will tell us we have the same scale factor. So in the end, comparing perimeters of similar polygons, if two polygons are similar, then the ratio of their perimeters, the scale factor of the perimeters, is going to be equal to the ratio of the sides, or the scale factor. So if I give you a side length and I tell you this is the scale factor, you can multiply to find the corresponding side length. Now if I give you a perimeter and I give you the scale factor, you just multiply the perimeter by that scale factor. Hopefully this made sense. Please search other videos if you need to, or ask your teacher if you have any questions.